Hi there, welcome to another Tidy Tuesday screencast. This is my second one, and today we're looking at cheese data. One of my favorite things about Tidy Tuesday already is that you're never really sure what the data is going to look like, where it's going to come from. So here we have it. They've given us 5 different data sets, and of these, the one that jumps out at me is the milk cow facts. I think I definitely want to have a closer look at what's going on with those cows. And when I saw this, the first thing that jumped into mind was that it would be a lot of fun if we could plot the points as cows. And so I Googled around real quick and I found this package called emojifont that was published middle of last year. And as I was reading and I scrolled down and I saw even the very first example plot uses cow heads, and I mean it couldn't get any better. This is one of the reasons you gotta love R. Like there's a package for it, right? Okay, so let's go ahead and jump over to R and get started programming and explore this data. Let's see, let's pull that R window up and here we go. So again, I played around just for a minute. We're going to come back. I got to clean this off. We'll come back to that. Anyway, let's go ahead and load up the libraries. And let's plot some data. So the first thing I wanted to do was just try a plot with this emojifont library to see how it looks. Now, the call is a little bit non-standard. They provide this geom emoji layer, which kind of works, but you have to put all of the data calls in that geom, not in the original ggplot call. Anyway, so let's do a simple like empty cars plot just to see what it looks like. I think this will work. Let's see. Boom. Look at those beautiful cows. So yeah, so there we go. We've got cows galore. Let me move my head out of the way so you can see the plot a little bit better. So it's pretty straightforward. Let's get into the data. So let's load some cow data. I think it's called milk cow facts, right? Yeah, milk cow facts. Okay, so let's have a look at it. I like using the, what have I done? Oh, jeez. I gotta put in that read CSV call, don't I? Let's try this instead. There we go. And now we can have a look at it and we can see that we've got year. This might be kind of tiny in the video, but average milk cow number, milk per cow, milk production, everything else. So let's see, let's just have a look at some of this data. So let's look at, how about the milk per cow and see if it's getting larger. So are we getting more milk out of each cow as the years go on? So the X here will be the cow data year, and the Y is going to be the cow data milk per cow. And it's going up. Yeah, so we had to fix the axis here. Obviously, it's auto-scaling this y-axis. So we'll set this to like 22,750 or something is the max. And that's a little more realistic, but yeah, it's still going up. You can see that in 1980, when the data set starts, the average milk per cow is about 1250, or sorry, 12,500, and I think that's in pounds. That's a lot of milk. And by the end of the data set, which is pretty close to current, anyway, we can figure out what the end of the data set is. it's almost double, like almost double the milk per cow. Let's see what the last year is. 2014. Okay, so the data goes up to 2014. Sorry, we're getting a lot of warning messages. I think this is something to do with that emojifont package. Hopefully it's not too frustrating to parse through. Okay, so let's see, what about the price per milk? I wonder how that's been moving over the years. And so here we're going to leave year as the x-axis, and then we're going to, average price of the milk by year. Okay, so that's a little bit interesting. Now we can see that the price looks to me to be pretty flat up until maybe about 2000, and then we see this big jump. I wonder what could account for that. So if we look at our data set, we have something like the milk feed price ratio, which I'm not sure what that is, but we can maybe look it up here. Let's pop back to the browser real quick and see if we can figure out what that milk feed price ratio is. The ratio of the average price of milk per dairy cow ration. And the dairy ration is the price paid for the dairy cow ration. I'm not exactly sure what a dairy cow ration is. We're going to need a domain expert to weigh in on that one. But maybe we can just plot the price of the ration over time and see if that relates to the price of milk. And look at that. So it looks like the dairy ration is correlating very strongly with the price of milk. Of course, we can plot them against each other to see. Let's set the X as the ration, and we'll set the Y as the price of milk. We'll sort of assume that the price of milk is the dependent variable. And that's kind of a strange looking plot. There's a lot of data clustered down here at the bottom. I wonder if it would help to log these. See if we can kind of normalize the scale a little bit more. I mean, maybe it helps a little bit. Spreads them out a tad, but it's still kind of a strange looking data set. So let's go ahead and plot. Well, let's make sure we comment our code. Okay, now let's see. Let's go ahead and fit a linear model. Of the ration price versus the milk price. We'll call this the milk model, and we'll just do an LM of the average price of milk versus the dairy ration. And let's just look at the summary of that. Okay, so let's see. It says that we've got a p-value of like 2 times 10 to the minus 9th. The r squared is about 0.67. So, I mean, looks like an okay model. The p-values, or the r squared, is not amazing, but I mean, it's not terrible. Now, the other thing I noticed was that we also have this alfalfa hay price, and I don't completely understand the difference between the cow ration and the alfalfa hay. I guess I don't really know what cows eat, but we could try to fit a model with both of those. Maybe they're eating both the rations and the the rations and the alfalfa. Oops, I overwrote the original model. That was what I wanted to do here. Let me fix that real quick. We'll call that Model 2. And let's look at the summary of that. So this one looks like a little bit of a better fit. The R-squared is just a touch higher, and the p-value is a touch lower. So we can plot those, of course. So we could do, let's do a mutate. Although I'm a little bit nervous because I think the alfalfa hay price might be in. Well, that's per ton, so that's okay. I just want to make sure that they're on sort of the same scale. I guess they're not really, because this is much higher. That's like cost per ton, and this is very cheap. The dairy ration is like 4 cents. So I don't know if that's the best way to combine those things. We'd probably want to normalize the data, but I'm going to skip that for right now. Okay, so I think I'm going to wrap this one up pretty quickly. I don't like to spend a ton of time on these, mainly because I don't think anybody wants to watch a video of more than about 10 minutes of me digging through our data. I'm surprised anybody would even do that much. But let's look at the stuff that we've done today. So we talked about the emojifont package that lets us kind of put these custom icons in our ggplots. The call is not standard, like I said. I'm not a huge fan of it, but there are ways to do this by labeling your data frame as well. So you can find this package in CRAN, and the documentation is here to have a look at if you want to play with it a little bit more. If you find out anything, definitely tweet at me I+4 and let me know what you find as far as using it. I think this is actually kind of a fun package. Lots of times it's these little touches on your plots that really make people enjoy them more than your standard symbols. So, and we also learned that milk price is going up quite a bit, as a matter of fact, and it maybe is related to how much we're paying to feed the cows. All right, I'm going to wrap it up there. Thanks for watching, and I will see you next week.